Hello and welcome to part 2 of step 23. So in this video, we're going to continue on with the overall theme of parallelograms. So both a rhombus and a square are parallelograms. They have particular properties that make them even more special. So I'm going to pull up the note card so that you guys can write those down. So go ahead and write these down in your vocab chart. So, a rhombus and a square are very, very similar to each other. So, a rhombus is the formal name of what you've probably learned is a diamond. So, essentially, a rhombus and a square follow almost every property. I like to think of a rhombus as a square that's kind of been squashed a little bit. So it's just kind of pushed on its side. So for a rhombus, the new stuff, so opposite angles are congruent, consecutive angles are supplementary, all of that stuff is the same from just a regular parallelogram and rectangle. We've already learned those things. The new stuff is what I've highlighted. Each diagonal bisects the opposite angles. And the diagonals bisect each other, which we already knew, and they're perpendicular to each other, meaning that when the diagonals intersect, they form right angles, okay? And just like a square, a rhombus, all four sides are congruent, okay? So the only thing that's changing between the squares and the rhombus is that all four angles are right, okay? This is the only one that's changing between this rhombus and the square. So if you follow everything that would happen in a square, it also happens in a rhombus. It's just that the four angles are right and that the diagonals are congruent to each other. Okay, but everything else falls in line. So it's kind of a square, is kind of merging the idea of a rhombus with a rectangle. Okay, so if you need more time, go ahead and pause the video. I'm going to go back so that this isn't another like 20-minute video, but, okay, a rhombus, so if a parallelogram is a rhombus, then its diagonals are perpendicular to each other. Okay, so in this picture, we had a nice right angle, so diagonals are perpendicular. Okay, which if you want to make a note for yourself, all this means is forms right angles. Okay, another thing we talked about is that the diagonal bisects the opposite angles, okay? So 5 and 6 would be equal, 1 and 2, 7 and 8, 3 and 4. They would all be equal to each other because we're being bisected. So if we really wanted to label them, we could go through and 1, 2, 3. Okay. All right, so we're looking at our first picture. So the diagonals of a rhombus, F, G, H, J, intersect at K. And then we have the given information. So F, J, H is 82. So if I highlight F to J to H, that big angle at J is 82 degrees. So this whole thing. Okay, so if we go back up and we look, so things that we know. Diagonals are perpendicular. So if we look back, these diagonals are forming right angles. Okay, the other thing they're doing is they're bisecting the angles. Okay, so if we look specifically at J, when this diagonal comes into J, it's actually splitting it in half. So if we take 82 and we divide it by 2, so 8 divided by 2 is 4, 2 divided by 2 is 1. So really each side of J it's split into 41 degrees. We are trying to find KHJ. So K to H down to J. So we're just looking for that tiny piece of H. So I've seen this solved a few different ways. Somebody thinks of a new way every year. So the way that I would think about this from what we have labeled is if we focus specifically on this triangle right here, JKH. If I focus on that triangle there, I know the three angles of that triangle should add up to 180 degrees. Okay, so if I did 90 plus 41 is 131, I subtracted that, I should get 49. So the measure of angle KHJ is 49 degrees. Okay, another way that has been suggested to me to solve this is, okay, if I know J is 82, then J and H, because they're next to each other, they have to be supplementary. Okay, so I've had girls say, okay, well, if they're supplementary, then 180 minus 82, they'll say, well, Miss B, angle, or Mrs. Duncan, angle H then has to be 98, and then that's also being bisected. So 98 divided by 2 is 49, which is the same thing. So however you think about it, there is not always just one pathway to get there. I'm trying to remember how many properties. Okay, so this will be the last one we do. We're looking at the same shape. Well, I guess on this problem. So same shape, I just copied it so we could write all over it. So we have GH is x plus 9, and JH is 5x minus 2. Okay, so we know in any parallelogram, whether it be a rectangle, a square, a rhombus, just regular old parallelogram, the opposite sides are congruent. Okay, so this side is equal to this side, and this side would be equal to this side. Well, a rhombus is a special parallelogram. Remember, think about a squished square. Has all the properties of the square, but it's just slightly squished, so the angles are 90 degrees. Because the angles are 90 degrees, it still stays true that all the sides are equal to each other. Okay, so all sides are congruent because it's a rhombus. So I can say, well, then I know that JH is equal to GH because it's a rhombus. So I can say 5x minus 2 is equal to x plus 9. Okay, I can subtract x from both sides. 4x minus 2 equals 9. Then add 2 over, 4x equals 11. This seems weird. 11 divided by 4 is 2.75. Okay, I'll give you a second to catch up. Sorry, I'm just making sure that looks really weird. Oh, that's right. So our answer is 2.75. We just had to find x. Okay, I'm going to save the next two maybe for class. Okay, then we're going to start talking about the relationship between squares and rhombi. So, like I was saying, a square and a rhombi share a lot of the same characteristics. A square is a perfect box where all the sides are the same, all the angles are the same, they're all 90 degrees. A rhombus is just kind of like a square at a tilt. Just kind of like smushed a little bit to change the angle measurements and change the diagonals a little bit. So, if we think about it, the umbrella of parallelograms, we have just regular old parallelograms, but we also have rectangles, we have squares, and we have rhombi. Okay, so this little Venn diagram, I really like this. You may not. understand, or you may think it's weird, but that's okay. So all of the shapes in here are parallelograms, okay? We have our rectangles on the left-hand side, which say that we have 4 right angles, okay? The rhombi are on the right-hand side, which says we have 4 congruent sides. Again, these are all parallelograms, so they're all holding the same properties as opposite sides congruent and parallel, opposite angles congruent, consecutive angles are supplementary. All of that is staying true, but a square shares both the fact that it has right angles and that all of its sides are the same. So it's kind of a merge between everything we know about rectangles and everything we know about a rhombi. Okay? So we're going to do one last example. Yes, this is the last one. I think, yeah, okay. So we have coordinates for some sort of parallelogram. So all we know is that it's a parallelogram. We're trying to decide, is this a rhombus? Is it a square? Is it a rectangle? Or is it none of them? Okay, so we have to list all that apply. Okay, so I'm going to go ahead and graph this. So -7, 1, 2. Okay, so we know this is a parallelogram for sure. Okay, one of the reasons we know that is we could do this a couple different ways. We could talk about finding the lengths of all the sides, comparing them. We could look at the slopes because the opposite sides have to be parallel to each other, so they would have to have the same slope. So like if I was looking at JK, I could go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So this slope would be 6/7. Same with LM. And then this one would be what? 2, 1, 2, 3, 4, 5, 6, 7. So 2/9 and 2/9. Sorry, these are the slopes. So since the opposite sides have the same slope, we could also prove that it's a parallelogram. But overall, we just know that it's a parallelogram. We're trying to figure out which one. And there's a few different ways that you could actually eliminate these, okay? One thing that stands out to me, just thinking about the basic definition of a rhombus, a square, and a rectangle, are that squares and rectangles have 90-degree angles, okay? So if we're looking at this picture, these angles are clearly not 90 degrees, okay? It would be way more obvious if they were perfect right angles than what this is. This is kind of like a stretched parallelogram. So, and that's not to say that the sides aren't equal to each other. That could still be true, but we don't have 90-degree angles. And if we don't have 90-degree angles, then we can already eliminate square and rectangle. So no 90-degree angles. Already eliminates. Okay, so if we look at a rhombus, so if we think about characteristics of a rhombus, it's like a square, but it's tilted a little bit. It's like squashed a little bit. So this picture looks like maybe the sides would be the same. We know we don't have 90-degree angles. We could find the diagonals. If this is a parallelogram, then the diagonals are bisecting each other. But at the end of the day, if we were to find all the lengths of each side, they would all be the same. So if all the sides are the same, but they don't have 90 degrees, regardless if they do or not, this would have to be a rhombus. So we could say that all sides are congruent. Oh, I forgot to put yes. Yes. Now just trust me that that's true. I could make you do distance formula, but that's really no fun. So we can kind of use process of elimination for these, and whichever property falls through that you don't see can't be that parallelogram. And that is it for step 23.